Welcome to this video lecture on the topic Biot Savart law and applications. So Biot Savart law is used for finding the magnetic field intensity. So Biot and Savart conducted an experiment on the force exerted by an electric current on a nearby magnet. So they arrived at a mathematical expression which gives the magnetic field at some point due to a current. So this magnetic field described by Biot Savart law is the field due to the current carrying conductor. So it is used for finding the magnetic field due to the current carrying conductor. So consider there is a current flow through a conductor of I and we are going to find your magnetic field at a point P. So what are the parameters taken is I into dl, it means the current element, and r vector, it is the distance between current element and point P, and the angle theta between current carrying wire and the straight line. So we are going to see the statement of Biot Savart law. So it is magnetic field intensity produced at a point P due to a differential current element I into dl is proportional to the product of current and differential length dl and the sine of angle between the element and the line, and inversely proportional to the square of distance. So it is related to Coulomb's law in electric field, where we use charges. Here we use the current element. So Biot Savart law's mathematical expression can be given as dH equal to I into dl sin theta divided by r squared. So it is proportional. So proportionality constant k is added and k is constant of proportionality, value is 1 by divided by 4 pi. So in vector form we can write the Biot Savart law using dl is magnitude of vector length and er cap is the unit vector in the direction from differential current element. So using the cross product we can write dl cross ar cap. So dl magnitude of er sin theta, it is dl sin theta. So using this we can rewrite the magnetic field equation of Biot Savart law, where IDL cross product of r cap divided by 4 pi r squared. So we can write r cap as r vector by modulus of r vector. So the equation is obtained as IDL cross r divided by 4 pi r cube. So this is the vector form equation of Biot Savart law, where we find the magnetic field intensity. So in terms of the integral form, we write for the entire conductor. So total magnetic field intensity is given as integral of IDL cross ER cap divided by 4 by r squared. And Biot Savart law in integral form. So this is written for the magnetic field intensity at a point P. So dH2 equal to I1 dL1 cross ER R12 cap divided by 4 pi R12 square. So I1 is the current flowing through dL1 and dL1 is the differential vector at length at point 1. So using this, H2 is calculated using the integral form. So Biot Savart law, in this distance is noted, the magnitude of magnetic field varies as the inverse square of the distance. Electric field due to a point charge also varies as the inverse square of distance. So the direction is electric field created by a point charge is radial in direction. The magnetic field created by a current element is perpendicular to both the length element and the unit vector. So comparison to electric field. So source of the electric field is the isolated electric charge and magnetic field is the current element. And we are going to apply the Biot Savart law to find the field at a point P due to the finite length current carrying conductor. So here we are considering the finite length conductor and we are considering the point P where we are calculating the H vector. So for this we are applying the Biot Savart law and we are going to apply cross product between IDL and the distance vector. So we get I divided by 4 pi rho, where rho is the charge density, into sin alpha 2 minus sin alpha 1. It is calculated from the previous diagram. And for an infinite long conductor, we can obtain H vector as I divided by 2 pi rho. So this is very important relation to find the infinite long conductor. Assessment. So find the magnetic field intensity for the finite current element with 2 amperes current and length of and height 1 by 2 pi. So we can obtain the magnetic field equal to H equal to I divided by 2 pi H. So because height is given as 1 by 2 pi, we can substitute this, so it get cancelled. 2 pi get cancelled, so H is, yeah, answer is 1. So the answer is option A. And second question, the H quantity is analogous to which of the following? The answer is C, because H magnetic field intensity is equivalent to magnetic electric field intensity in electrostatics. These are the references. Thank you for listening.